Let's get started. So I'm going to go ahead. So I'm going to bring this down to a next page here. So we know where to start. Oh, I can't do that yet. You. All right. So let's get started here because this is where we kind of ended. So we're going to get more into equations. But I'm going to talk about, in case we don't get to those particular parts, how do we go about solving these type of equations. So over here, when we're given this, down the road I'm going to give you a different way that you can actually solve for this, right? There's actually a different way. However, for now, you'll get these type of problems if the other things, if 6.5 and 6.4 wasn't taught, then this is the only way that you can do it. So here, if we have a base raised to a power where the power has the exponent, or the power has the variable that we're solving for, in other words, the x, then what we have to do is get the base to be the same base, right? So I can write 64 as a base of 2. I can write 128 as a base of 2, but I can't write it for any other power, right? Because I can't write 64. I can't write 128 as a base of 64, right? Because 64 squared is not 128. But I can write 64 as 2 to the 6th power, and then raise that to this power here. That I can do. Okay? And then I can write 128 as 2 to what power? What's 128? 2 to what power? To the 7th power, bless you. And then raise to that, and raise that to the x. But you guys should already know this, right? Because you guys should know that 32, oh, sorry, I'll start. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024 all has a base of 2. Because those you actually deal with every day. Right? It's the amount of storage that we have on our phones. You don't have a phone that has 100 gigs of data, of storage, right? There's no such a thing. It's either 128, 256, 64 is usually those. Your computer, not just your storage, but also your memory, right? Your RAM is also in those increments because everything with the computer is binary, right? Zeros and ones, ones and zeros, right? Trues and falses, yeses and nos, right? That's why it's all powers of 2 or base of 2, okay? All right, so here, when I raise a power to a power, I got to multiply the power. So this is essentially 2 raised to 6 times negative x plus 26 is equal to 2 raised to the 7x. So since the bases are the same, then the powers must also be the same. Since the bases are the same, the power must be the same. So we would just solve from there. Log sum Is that right? Someone check my math. I like it. Put it side by side. Nice. Yeah, Desmos doesn't do a split screen. Any questions there? Jenna, I hope that you're stopped and you're not writing notes while you're driving. On this example here, we get to the natural number of e. E is actually a number, right? E is actually the natural number is like 2.71 blah, 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 right? You can actually type that in your calculator. You type in e to the first power, you'll see that number 2.71 dot, dot, dot. So e can be a base because it's just a natural number, just like pi. Pi is a number that has no end, right? In fact, they give a lot of money now if you can find the next digit of pi. You just got to find the next digit of pi, and you can get a ton of money for it. Except it might take you 20 years to get that next digit. Because it's that deep. And you got to remember how many digits of pi already been found. And how long that number is so far. You're like who verifies that I got the right next digit? Right? There's only 10 digits. Yeah, like who verifies that? Going, oh yeah, that was right. Here is your money. Like I don't get it. I don't get it. All right, so E, since the base are the same, that means the power must be the same. So right here, because E's are the same, no, I'm just going to leave it alone. Minus 3 is equal to 2x. I see a square term and an equal sign. What should I be thinking of? Correct. Quadratic equations. Good job, guys. Way to answer. Yes. So anytime I see a square term and an equal sign, I should always think quadratic. So that means I got to bring everything to one side and factor the non-zero side. Right? And if I factor this side, what am I going to get? X minus. Excellent. Yep. So I got x is equal to 3, and x is equal to negative 1. Good news is there's nothing to check here. However, when I get to logarithms, I do have things I need to check. So the next part here, I'm just going to remind you of this in terms of transformation. So the one thing I always say, well, when I talk about transformation, the one thing that I say is this. So if you guys look at this right here, right, we always have a coefficient in front of the base. We always have it raised to some kind of power. And then sometimes we'll add or subtract. So what I tend to tell my students about this right here, anything inside the parentheses is backwards, opposite, and SADMAP. So I'll go ahead and bring this down because I think that's important. So inside the parentheses, it's SADMAP. Do we know what SADMAP means? It's PEMDAS backwards. So even the order of operations in there is backwards. So if it asks me to subtract D, that means I have to add D. And also, this affects the what value? Affects what value? Yeah, I'm sorry. The X value. Okay? So that means the D is a shift left to right. If it says minus D, that means I add D. That means I'm shifting to the right. Okay? And plus D means I'm shifting to the left. The B, if it says to multiply by B, that means I have to do what? Divide by B. So again, that affects the X. So if I had an X and it told me to multiply by 2, that means I divide by 2. That means I just had a horizontal shrink. Does that make sense? If it told me divide by 2, that means I got multiplied by 2. That means that I have a horizontal stretch. Okay? There's outside the parentheses. That affects what? And everything's straightforward. Right? So this is going to be PEMDAS and straightforward. Oh, no, just a number. Yep, it's not the natural number. Thank you. So when I add E or subtract E, that would be a vertical shift, right? Meaning, am I shifting up or down? The C is multiplying, and it's straightforward. So if I multiply by 2, I double the height, right? That means I have a vertical stretch. If I divide by 2, that means I have a vertical shrink. All right? So let what it is, where it is, to identify what is, how it's affecting it. Okay? Because here's the honest truth, right? If I did a vertical, if the green giant came up to me, grabbed me by the head, my neck and my feet, and just went, I had a vertical stretch. He pulled me vertically. Horizontally, I look skinnier, but you can't say that horizontally I was skinnier because he pulled this way, right? If he decided to smush me this way, then you can say, yes, I got skinnier because he went horizontally. Does that make sense? Okay. If he pounded me on the head, I vertically shrunk, even though if I splatter left and right. Okay? So be careful what you say as you're doing these things. Is that fair? Okay. Now here's my question. If this B was negative, how does it affect the graph?
It negates the X value.
Which does what? You're right. Just say it with confidence. It flips over the y-axis because it affects the x value, right? So if you think about this, if you look at me right now, right? X value went from positive to negative. So it has to flip over the y-axis, right? If C was negative, what does it do? Yeah, right? It affects the y value. So y value went from positive to negative. So it has to reflect over the x-axis. Does that make sense? Okay? I should probably write that down. So negative b okay? I should probably look at your lab work to make sure that you don't have things that I need you to show, per se. Oh, there is. Okay. So, any point in time, you see that you have to do some kind of transformation. Okay? Like I see one in your lab work, number 6 is telling you to graph the function. So essentially, if you look at it, you'll see there is a transformation there. All right? So whenever we're doing a transformation, we always, number 1, so we always get 4 points from the parent function. So we look at this example right here. So when we look at this right here, right, what we have to understand is that the parent function here is y is equal to 6 raised to the x. Okay? Nothing else. The rest of the stuff is just frills. It's just extra stuff, right? That's the reason why what we would do is we will come over here. That is my parent function. I'm going to get 6 points from there. And those 6 points could be whatever you choose. I'm sorry, 4 points. So if that's the case, the domain of an exponential function is negative infinity to positive infinity. So you can pick 0, 1, 2, 3, right? So 6 to the 0, 6 to the first, 6 squared, 6 cubed. Oy. What's 6 cubed? What would be 6 to the negative 1? Nope. What would be to the negative 1?
No, 1/6.
Because it doesn't like being on top, so it moves to the bottom. Right? Because this would be, that would be 6 to the negative 1 power. Doesn't like being on top, so it moves to the bottom to be a positive power. So it'll be 1 over 6. Right? And then 1 over 6 squared, and so on. Okay? So we'll pick 4 of those points, and then we will move it over here. So therefore, I have, let's say I start with 0, 1, 236. Oops, I forgot. I totally just skipped 1, didn't I? Then from there, I would address each transformation. So if I look at this, what do I deal with first? I have to go inside. I got to do parentheses first, right? Because when I look at a problem, I do parentheses first. So here I would subtract 1 first. Everybody see that? So here I would take this part right here first. Let's call it green. So I'll do that first. I got to subtract 1 from what value? And I'll get 4 brand new points. And what happens when I do that? When I subtract 1 from the x value? What's the next thing I do after that? Did I finish everything inside the parentheses? Yeah? So I come back out of the parentheses. What's the next thing I do? Do I go down 2? When I come out of the parentheses, I go back to the order of operations, right? So what do I do first? Do next? Yeah. I got to multiply what value by -1? The y value. So I got to multiply by -1. Now what do I do? Oh, I'm sorry. I forgot to say this. This is reflect over what? X-axis. And then last, I subtract 2 from what? The y value. And that's going to be a shift what?
Is the reason why you multiply it by -1 and not -6 because -6 is acting like a base?
It is a base.
Coefficient?
Yep. So, and here's the thing, right? So if you look at this, if you go back to when we talked about the exponential function, there's always a coefficient in front of that base. And yes, 6 is the base, so that negative is actually a -1 times that base.
So if it's just a number there, and then there would be a +1 or a -1
Correct.
coefficient
Correct.
instead of like a number,
Correct.
a different one.
Correct. So like if you look at this right here, essentially you could look at this as is that fair? And that's the reason why I gave you guys this thought right here that we could find that coefficient, or we can't find the coefficient. We will have to use first find our base, then from that use it to find our coefficient. Okay. Any questions there? Now, don't get me wrong. So this purple right here is your final answer. So if I was to go to Desmos, right, and I'm not, so this is obviously not something you can do on your lab work, but if I say y equals 6 raised to the x, right, you have that right there. And then someone's going to have to remind me here, y equals, what is it, -6 raised to the oops, negative 6 raised to the 1. Right? So you guys can see right here of what happened. Right? Shifted left 1 unit, flipped over the x-axis, and then shifted down 2 units. Right? You guys can picture that. Make sense? Okay? So the blue is my final answer, but there is a couple of things that came between them. Okay? Now, again, here, on the red line, there is a horizontal asymptote. Is that true? And the horizontal asymptote is at y equals 0. So let me do this. All right? And remember when I talked to you about how that horizontal asymptote and this point is always 1 unit away. Agreed? Okay. So if you look at the second equation, the blue line, I want you guys to actually, you know what I can do? I can just do this. The blue line, that's its horizontal asymptote. Okay? Which is y equals negative 2. Okay? So here's my question to you. Where is the blue curve 1 unit away from its asymptote? Can anybody tell me? Where is the 1 unit away? What's that point? 1 unit away. Negative 1, negative 3. Everybody agree? 1 unit away is right there. Yes? Okay? So my key point up there was 0, 1. Okay? And 0, 1 had to shift to this point by shifting left 1, flip over, down 2. Okay? So the question is, so if you look at just a horizontal asymptote, it shows me that there's a shift down of 2. Agreed? So what I'm trying to say is, if I was to give you the blue line, or blue curve, could you write me the equation from the red curve? So you didn't know what the shifting was, right? Could you write me this equation? All right? So this is what I'm trying to show you guys, how to write that equation. If I was to give you the blue curve, again, if I was to give you the blue curve, could I write the equation from the red curve? So I tell you the parent function is 6 to the x, but I want you to write the equation for the blue curve. So my first step in my mind would be, okay, horizontal asymptote of the red line to the blue line was a shift down in 2 in the y direction. So I already know there's a minus 2 at the end. Agreed? Now I look at 1 unit away. What kind of shift did I go left and right wise? I went left 1 unit, didn't I? So that means inside the parentheses I got a plus 1. Everybody understand? I can see that there's a reflection over the x-axis, which means my y went from positive to negative. So there's got to be a negative in front of that 6. Is that fair? Now, the question is, could that negative be a negative 2 or a negative 3 instead? Right? Because those things could happen, right? So what you would do is now test some points on the blue line to see if it is off. Does that make sense? Because if it's off, then you guys can figure out what that c should be. Is it a -1? Is it a -2? Is it a -1/2? That's going to tell you when you test it. Is that fair? Okay. So if I had to find the equation from the red parent function to the blue, I can do that. I'm able to do that. Okay. So you guys just got to be, that's why I kind of want to bring it up to you guys just so that you guys can see those things. All right. Any questions on there? So when you're showing on the lab work, make sure that you get 4 points from the parent function. And then you go into what each step is going to be and show those steps. Show those new points. Okay? Any questions there? So I'm going to remind you again, this is the exponential function, right? F of x is equal to, and most of the time we don't even talk about c anymore. The c is really only there when we're talking about transformation, but we mentioned it. However, I want to bring this up because the next part that we're going to be talking about is the logarithmic function, which is the inverse of the exponential function. Okay? So on the left, I put down as a reminder what exponential function was, right? So we had some key points here, right? Where I said before y is equal to 6 to the x, 6 to the 0 power is 1. 6 to the first power would be 6. 6 to the -1 power would be 1 over 6, right? So usually these are looked at as key points. We have a horizontal asymptote at y equals 0. Okay? My domain is -infinity to +infinity, but my range is 0 to infinity. Not touching 0, right? Yes?
When you're finding the 4 key points, is it a good idea to always use -1, 0?
I think so, but a lot of people wouldn't want to deal with a fraction. That's why when I showed that, I was just like, let's just do 0 and on, because a lot of people don't want to deal with a fraction. But the -1 is a good idea to do only because it reminds you that those are key points, but that's about it. Okay? All right, so if the logarithmic function is the inverse of this, okay, is the inverse, how do we find inverse? Huh? How do we find inverse of a function? Do we remember?
Well, I think it's dependent on what we're given.
No. No. Huh? No. Switching the x and y. Switching the x and y. So the word inverse means to switch the x and y, and not just that, the switching the x and y, it actually creates a reflection over the line y equals x. Okay? So let me show you guys that. Man, all these things are taken up. So let's see what that line looks like. Boop, 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 boop. Oh, you piece of... So this line right here is the line y equals x. So notice what that line is actually saying, right? Your y is equal to your x is equal to your y. Hence, the inverse is switching my x and y, right? So if I'm switching my x and y, that truly means switching your x and y. So if I look at my points, what's 0, 1 going to be now? 1, 0. What's 1b going to be? B1. And negative 1, 1 over b is now going to be what happens to my horizontal asymptote? What's that going to be now? It's not a horizontal asymptote anymore. It is a vertical asymptote. What happens to my domain and range? Ah, someone just said it. Hey. I always have problems drawing this thing. Dang it. We'll call it close enough. And someone just said something about domain and range. What did they say? It switches. So the range is now domain. And the domain becomes the range. So what does a domain of 0 to infinity mean? Yes. So notice what you just said. The x cannot be 0 nor negative. The x cannot be 0 nor negative. Okay? So remember that. Now, this means that my logarithmic function, if this was my exponential function, and I have to switch to x and y, would now be x is equal to b raised to the y. We call this, and this is the confusing part about logarithms. This is called the exponent form. So in logarithmic functions, there is actually an exponent form and a log form. The log form is going to look something like this. And yes, that base is a base of b. This is the log form. So remember one thing. This is called the base. That's raised to a power. And this is also called the base. So in both of those forms, b is still the base. Now, there are other log forms that you're going to see. You're going to see this. This is called the common log. as you see, you don't see a base right there, do you? Well, when there's no base, you know what that means? Mm-hmm. The base is 10. That's why it's called a common log. And on your TI, when you look at it, you see log and you see ln. Those are two different logs on there. The other one is your ln. This is called your natural log. And remember what I said about natural log. It has a base of e. The natural number, e. Actually, let me write that more like an e and not like an L. Is that more like an e? Okay. So that has a base of e. I don't know why they put it as ln. I don't know if it's supposed to be like log de natural, right? But it's a natural log. We have to be able to convert this back and forth between the exponential form and the log form. I can tell you a story through it to help you out. I can give you the rules of log to get you there as well. Okay? So I have to be able to go from log form to exponent form and vice versa. So this is the way I look at the story. See this base right here? This base says to his boss, hey, I've been your base for so long, but you clearly have been a log to me all this time. Right? So I'm leaving you, and I'm going to be the base on the other side. So when it becomes a base on the other side, it's going to be 3 raised to the c power. The problem is that Mr. Log here didn't realize he was being a log, so he gets all depressed and he goes away. So I just went from log form to exponent form. The base just moves sides and becomes a different base. It's still a base, right? Just a different base. Similarly, I can look at it this way. When I go from exponent form, this is still a base. It's like, boss, I've been working here for a long time, right? So he's like, I'm going to go ahead and be the base on the other side. So he leaves to be the base of the other side, right? So what happens that the boss on the left side is like, crap, now I got to find a new worker, but during that, before I find a new worker, I'm going to have to come down and work. And of course, then the log comes into play. Because in order for it to be the base on the other side, the log has to come into play. Because there was no log to start with, now a log comes in. I'll show you the rules that come into play to make these things happen. So don't worry about that. And for the ones that took my college algebra, you guys saw these as well. So if I had to evaluate this equation here, I don't know off the top of my head what log base 2 of 16 is. So I would convert this to exponent form for that to happen. So again, the 2 tells the log, you've been a log to me all this time, I'm leaving. I'm going to be the base on the other side. So y becomes a power. And this way I know that y is equal to 4, because 2 raised to the 4th power would give you 16. However, you could also make 16 a base of 2, 2 to the 4th. And if the bases are the same, the power needs to be the same, right? So hence y is equal to 4. So you might be asked to find a domain. Just like we had with fractions, and just like we had with square roots, we had restrictions, right? Oh, coffee shop is here. I didn't even realize they were here today. They're usually parked right here in the morning. All right, so one of the things that we started to realize is that the log has a domain of what? 0 to infinity. Is that right? So having a log that has a domain of 0 to infinity, so again, log functions, domain, what does this mean? You cannot take the log of 0 or negatives. So if you plug in your calculator log of 0, it will flip you off. If you take the log of a negative number, it's going to slap you across the face. Man, if a calculator could actually do that, you guys would like, it would be like instilled in your mind. You'll be like, got it. Can't take a log of a negative. I already know that. Not even going to even test that one. Because the last time I got slapped in the face, right? So here, when you look at this, there's actually 2 restrictions here that I got to look at, right? What's one of them? So, okay. So here's what he's saying, and she is saying. What they're saying is a couple of things. So based on this truth here, right, that I cannot take the log of a 0 or negative number, what I know is from that truth, I can say that x plus 1 over 1 minus x has to be greater than or equal to 0. Oh, sorry, greater than 0. Sorry. Is that true? So that's one thing I have to set. So is this true, though? That what's inside here has to be greater than 0. Because I can't take the log of a 0, and I can't take log of a negative number. So it has to be greater than 0. That's one fact. The second fact is that I know that 1 minus x cannot equal to 0. True? When is a fraction equal to 0? When the numerator is equal to 0. So that means that x plus 1 has to be greater than 0. That means x has to be greater than negative 1. Right? I know that fact. The other fact is over here that x cannot be 1. So when I put that on the number line, if I have negative 1 and 1, I know that 1 I'm going to have an open circle, well, or a weird looking parabola. I'm going to have an open circle there. That is for that part, right? And for -1, that says I can have it greater than -1. So at -1, I'm going to have an open circle, but I'm going to have this arrow pointed to the right. Does that make sense? Right? So again, this helps me to write what I need to write as my domain. Because that's going to tell me that's going to be -1 to 1 union with 1 to infinity. Yes?
Wait, so if we took a value higher than 1, positive 1, wouldn't that make it a negative?
Ooh. Ooh. He is right. Could I have that? Because you're saying if I use 2, the numerator is 2. I mean, the numerator would be 3,
How the denominator...
but the denominator would be -1. Ooh. How would I address that in my equations then? How would I address that? He's got a great point there. Go ahead.
It would just be from -1 to 1.
Uh-huh.
Wouldn't need the union and then the 1 to infinity.
Because I can't go less than -1 either, right? Because -2 would give me the same issue. So how do I put this in the equation? So which one of my equations is incorrect then? Because something in my equation's got to be incorrect. Is my inequality incorrect or my equation incorrect? Right? So, because based on my equations, this should be the truth. So do I need to do this and test some points to make sure? Oh, wow. Party Plus is here. Are we having a party here at FSW that I don't know about? It's Taylor's Rentals. Are we going to have a bouncy house and a sled?
Instead of 1 minus x should not be equal to 0, it should be 1 minus x should be greater than 0.
No, well, the 1 minus x not equal to 0 is appropriate, right? Because that's the fraction part. Because that's why we wrote it, is only because it's the denominator. So that means this inequality, there's something wrong with that. So what's wrong with this inequality? Huh?
Because if it's greater than 0 and then you divide it by a negative, then it's always going to be a negative. But if we make the numerator able to be negative, then when you divide it through, it would be positive, which means it's what's wrong.
But the problem with if the x was negative, then this would be positive, this would be negative. Right? Because if we use like -2, this becomes positive, this becomes negative. So we're back to negative again. So there must be something wrong with this inequality to make this not work.
X should be greater than or equal to negative 1.
that won't work either, because that would just make that a solid. It would make this solid. And then if we put a -1 in here, it'd be 2. -1 here would be 0, so it'd be 0 divided by that, which is 0. Then you can't take the log of 0. So that's why that can't be that. The question is, how do I deal with this part here? How do I know to not use this arrow? Do I have to test it? Because you're the first time someone questioned it. And it's very true. Because if you go in my video, that's the answer on there. So as much as you're trying to figure it out, I'm trying to figure it out too, of going, what's wrong with my inequality? And I know in this class he's going to question things. He's going to be like, hey, but 2 doesn't work, bud. So that arrow can't work. And 3 won't work. So does it mean we have to test it then? It might just mean that we actually have to test it, and since it doesn't work, we're going to have to go, okay, that goes away, and that goes away. And that's my answer. Because he's right. If I use 2, it won't work. Ooh, I wonder let's see what this graph looks like. Now I'm curious. It was log base 5 of the fraction, what was it? X plus 1 over 1 minus x. Oh, wow. It looks like it ended too. What the heck? What's that? What the? All right. Now I'm confused myself. Are you guys confused? Because I'm confused. Huh? Remember what we said. It was going from -1 to +1 without touching -1 or +1. Because those are asymptotes. We can have negative x values. And that's what I'm trying to say. This is saying to you that I can't take the log of 0 or the log of a negative number. It doesn't mean that my x can't be negative. Similarly, if I was to say to you, and I'm loving these questions, by the way. If I was to say to you, square root of right? The x can still be negative, right? Or even, let's go this route even. Let's make it even more obvious. The x can still be negative, right? It just can be negative to a certain point until I start taking the square root of a negative. That's when the no-no comes into play, right? So I can have -3, -2, and -1. I just can't use -4. Because -4 is going to force me to take the square root of a negative number, right? That's the reason why I put this down here. I can have x values be negative. I just can't take the log of a negative number or a log of 0. Make sense? Okay? That's why in here you'll see negative x values because I can use those. It's just after -1, now I'm taking the log of negative numbers. And after +1, I'm also taking the log of negative numbers again. Okay? And that those two things are, well, that one thing is a no-no. Okay? All right. Maybe I should, next time I record this, I'll use a different equation. But does that make sense, though? Okay? Yes?
How would I write that in exponential form? It
It'll be 5 to the y is equal to x plus 1 over 1 minus x. Because the base would just go over to the other side. And then the log goes away. We okay? I'm still trying to figure out what's wrong with that inequality. It would have to, because then it's only going to raise to one of the powers and divide the whole thing. Oh, no, I mean, nope. All right, so let's talk about these properties. Now, you guys are seeing 12 different properties, is that right? That's what you guys see, but it really is only 4. It is the same property for the different logarithms. This is for log base b. This is for the natural log. This is for the common log. It's exactly the same. Log of 1 is 0. Log base something of 1 is 0. Natural log of 1 is 0. Because we have the point 1, 0. Right? We have the point 1, 0, so that's why log of those number of 1 is going to be 0. And the other 3 are just literally the opposite operation. I should say 2 and 4, rows 2 and 4 are just opposite operations. So if you look at the middle, ln and e are opposite operations. Okay? So I want to remind you guys something here as well. You guys ready? If you type in your calculator log, what happens right away? Do that for me. Hit log, and what happens right away? What shows up right next to the log? Parentheses.
So it doesn't give you
Yep. Yep. But it gives you a parentheses right away, doesn't it? Okay? The reason for that is because you have to take the log of something. Just the word log means what I dropped in the bathroom a couple hours ago. Okay? If you just write down the word log, is either what I dropped in the bathroom or what you burn in a fireplace. Okay? Those are logs. So you got to take the log of something. Okay? When you're at a base, like e, you got to raise it to something. Okay? E doesn't mean anything besides a letter if you just wrote down e. So if you were to type e on your calculator, it's going to be e raised to some kind of power. Okay? So that's why next to every e or b for base, you see it raised to some kind of power. Maybe I should do this too. Maybe this would help division. Would that help? So when I ask you a question, you're like, log. I'm like, great. Of what? E. Okay. Raised to what power? All right. So you'll always hear those things. So again, row 2 and row 4 are opposite operations, just like a squared with a square root. So for log base b, as long as the bases match, wherever b is raised to that power, that's all that's left because log base b and b are opposite operations. Natural log and e are opposite operations, so they cancel each other out, so just the p is left. Right? Log base 10 of 10 raised to a power, same thing. The bases match, so that's why only p is left. And row 2 and row 3 are exactly the same, except the powers to the first power on the row 3 instead. That's all it is. Right? And then 2 and 4 are just mirrors of each other in terms of opposite operation. Okay? So remember when I was telling you the story about the base saying, thanks for all the opportunity, I'm switching sides, right? So same idea. So if I was to see this right here, and I want to convert this to log, or let's say solve for y per se, right? Then what I would do is go, okay, I see that this is a base b. So the opposite operation of base b would be taking the log base b of this. And since I did it to one side, I have to do the same on the other side. Because wherever I do the one side, I do the same to the other. Does that make sense? On the right, the log base b of b would leave me left with just a y, and nothing simplifies on this side. And there I go from exponential form to log form. Exactly. On the right side would be like squaring a square root, or taking the square root of a square. Okay? And if I wanted to go back the other direction, because I see on this side that I have a log base b, the opposite operation of that is using a base, raising it to that power. So that means I will have to do the same thing. Take the b, raise it to that power on the other side. So if I do that, then what I have left is b to the y is equal to x. And that's how you go back to the exponent form. Right? So it's these properties that help me get to where I need to get to. The picture on the left is just to remind you guys of the logarithm graph. And then same thing here. So anytime I have this right here, there's no other side. Right? So I can't say 5 raised to the log base 5. Right? Because I can't do 5 raised to something on the other side. So the only thing I can do here, guys, is when I see this base, I'm going to try to make the number also with the same base. So in other words, I can write this as log base 5 of 25 being 5 squared. So now you see the log base 5 and the 5 are opposite operations. So this is just going to come out to be a 2. Gesundheit. Does that make sense? Yes? We're good there? Any questions? Nothing? I hope you guys really don't need this. Does it make sense though? Because all I'm saying is if the bases are the same, then the power must be the same. So in other words, if I was to say 2 squared is equal to 2 to the x, what is x equal to? Yeah? Does that make sense? Because the base is the same, the power must be the same. Or if I said ln of 2 is equal to ln of x, what is x equal to? 2. Right? That's all this part is saying. So it's not really anything special. So I have 2 raised to the x equals 2 to the 5th. What's x equal to? Do you want to think about it? Example on the right. What's that going to equal to? 2 to the 6? So that means 2x plus 3 is equal to 6. So x is going to equal to what? Yes? Oh, this is going to be a special one. Here, bottom left. How do we get those bases to be the same? What's 1/3 going to convert to? Ooh. Okay. That's one way to do it. I'm good with that. So he decided to go to make 9 to be a 1/3 power. Hello? Okay, don't do anything. So he decided that he's going to convert the 9 to the 1/3 power, which he says that is going to be 1/3 to the negative 2nd power, and raise that to the x minus 5. Absolutely possible. The other way, I can convert 1/3. Well, you know what? I'll have to convert both in this case. So his way is more, what's the word? More efficient. Because I can raise this side here as 3 to the negative 1 power. And this one here as 3 squared raised to the x minus 5 power. Right? Either way, I'm going to get to the same exact x value. Same equation, actually. Almost the same equation, I should say. Because the top one is going to give me 6x plus 4 is equal to negative 2 times x minus 5. And the bottom equation is going to give me a negative 6x plus 4 is equal to 2 times x minus 5. The negative is just in a different direction, right? So they're both correct, absolutely correct. Now, since we have a little time left, how do we deal with this here?
I believe you would add the 12 on both sides, and then since 4 pound x and negative 6 pound x have the same exponents, they can be subtracted.
It cannot be subtracted.
Would you put 4 base 2 this side?
Oh.
Is that what you were going to say?
No.
What were you going to say?
I was going to say, 4 squared is
4 square, 4 what? But where are you getting the square from? Yeah, you couldn't combine those. So what she was saying was, hey, I can write 4 as 2 squared raised to the x power. Right? Say that again.
I think 2 does work as an answer, but I'm not sure.
It does. However, you might be looking at this going, wait a minute, how does this help me?
You can then move 12 like that.
No.
No?
Check this out. Is what? Doesn't that look like a quadratic? All right, so let me introduce you to U substitution.
I've heard that word before.
Mm-hmm.
I don't remember what it means.
So all it means is this. So as you guys are looking at this, I see a square term, then to the first power, then to no power, equaling 0. Which is a quadratic, right? ax squared plus bx plus c equals 0. Okay. So with U substitution, all I'm doing is I see that the 2x is in common. So I'm going to go ahead and let 2 to the x equal to u, hence a U substitution. So if I did that, I'll have u squared minus u minus 12 equals 0.
That's a quadratic.
Bingo. That's why when I saw square and then 1 power, 0 power, and then equal to 0, I already know it's a quadratic. But this makes it really look like a quadratic, right? Then from here I can go, oh, look, this is u minus 4, u plus 3 equals 0. Yes? Well, the problem is that my equation has raised to the x, so now I basically put things back where it's supposed to be. So now I'm going to say, okay. So typically I would say u minus 4 is equal to 0, and u plus 3 equal to 0, right? True? And u is equal to 4, and u is equal to negative 3, yes? Everybody agree? Okay, so now we just put it back. So we got 2 to the x equals 4. 2 to the x equals negative 3. Can they both work? Two raised to what power gives me negative 3? Good luck. 2 raised to any power, can I get a negative number? No. But I know that 2 squared gives me 4, doesn't it? Oh, crap. That took too much of your time already. Because now we still got expanding and condensing. I feel bad now. Let me look at your lab work. Ooh, there is expanding. Lots of expanding. Well, only 2. 8 and 9. Shoot. Okay, let me do it this way. Let me give you guys the steps before I let you guys go. All right, so when you're expanding, The way I look at expanding is this. When I used to have a dog up north, during the winter time, my dog would expand her logs everywhere in the yard, right? So it's everywhere. It's expanded. So that means it went from one log to multiple logs. When the springtime came and the snow melted, I had to go in the yard and condense all those logs into one pile of log. So if you have multiple logs, that means you got to condense it to one log. So if you look at my examples here, come on. This first example here has one log. That means I have to expand it. Here, this example, I got multiple logs. That means I have to condense it. Does that make sense? Okay. So with expanding, the first thing you're going to do is that you're going to use the product rule and the quotient rule. Then you're going to use the exponent rule, or the power rule. Sorry. Which means that you're going to have to try to convert every single parentheses, every single square root into a power. And with condensing, is exactly opposite. You're going to deal with the power rule first. Then you're going to use the product and quotient rule. Okay? I'm going to ask you guys to do the best you can. If you don't remember, do the best you can. If not, I'm going to try my best not to grade 8 and 9. Is that fair? Okay. So other than that, ladies and gentlemen, please have a wonderful, blessed weekend. Please be safe. Love you guys. I'll see you guys next Tuesday. Later.